Hey adapters, welcome back. Today my guest is Dr. Jay Keasling. Jay is the CEO of the Joint Bioenergy Institute and is a pioneer of synthetic biology. His research focuses on engineering microorganisms to produce useful chemicals. In the early 2000s, his team engineered yeast to synthetically produce artemisinin, the powerful anti-malarial drug. Researchers in his group are now using the same technology to produce biofuels and bioproducts from biomass. Jay will explain what biofuels and bioproducts are and how they are engineered and how they can impact the daily lives of the general public. He addresses the common misconceptions of biofuels and bioproducts and explains which sustainable fuel types can only be produced through these processes. Hey Jay, welcome to the show.
Thanks, Doug. It's great to be here.
Okay, we're going to be talking biofuels. I love talking about this subject because I have so much to learn around it. But first off, could you tell us a little bit about JBEI? What is that?
Yes, so JBEI is funded by the U.S. Department of Energy. They fund us to do basic science on how to transform cellulosic biomass into useful biofuels and bioproducts. Cellulosic biomass is the basically plant material. It's the stalks of corn, it's trees, it's grasses. We generally focus on cellulosic biomass that isn't consumed by humans. So things like switchgrass, which is a native of the US prairies, grows natively, doesn't need a lot of water or fertilizer, and has a lot of sugars in its mass that we can then transform into biofuels and bioproducts.
Okay, so a lot of this is about replacing things that are made out of petroleum, but would people be surprised about all the different things made out of petroleum?
There are so many things made out of petroleum. We say we're addicted to petroleum. We're addicted because it supplies most of the fuel that we use in our cars, trucks, trains, and airplanes. But it also supplies most of the products that we use, like a lot of synthetic fibers, all kinds of plastics. All of these things are made of petroleum. In fact, it's been said that 100,000 different types of chemicals are made from petroleum.
Wow. Well, okay, so we have all this fossil fuel in the ground, and so for us it might be obvious, but why is there a need to make things through biology?
Well, the first problem is climate change. So we're taking carbon that's stored underground, we're formulating it into fuels, burning them in our cars, and then the exhaust puts the carbon in the atmosphere in the form of carbon dioxide. And so we keep adding carbon dioxide to the atmosphere, and that then is warming the planet. So that's the biggest challenge. A second challenge is that many of the products that we make from petroleum are harmful in and of themselves to the environment. Let's take plastic, for instance. Plastic, when it isn't recycled and is just thrown into a landfill or thrown into the ocean, can last for decades, centuries, even in some cases. And this is causing a huge problem for our environment. And there's these large gyres of plastic that are like the size of the US that are accumulating in the oceans. We have to stop this. We have to make fuels that won't add carbon to the atmosphere, biofuels, and we have to make new bioproducts that won't accumulate in the environment, that'll be good for the environment and still useful to humans.
Okay, so I think there's actually a lot of misconceptions about biofuels out there. There's different type of biofuels, the production of biofuels, but what are some of the big misconceptions around them?
Yeah, one of the big misconceptions about biofuels is that they're made from food crops. And it's true that a lot of ethanol has been made from corn. This is corn that would normally be fed to cattle. And so as a result, we're diverting some of the food supply to making ethanol. With the cellulosic biofuels that we're working on plant biomass that would not be fed to humans, would not be fed to cattle, but would just be wasted. And in the case of California and forests, would end up burning and causing even more problems. So we have a chance to alleviate that problem as well as not put more carbon in the atmosphere. Another misconception about biofuels is that they're ethanol. And ethanol is a great additive for gasoline, We use it in many parts of the US up to about 10%. But because our cars aren't flex fuel, we can't use more than 10% ethanol in them. If we were in Brazil, for instance, where they have a lot of flex fuel cars and in some cases use 100% ethanol, it would be different. So what we're trying to do with biofuels is produce biofuels that will directly mimic the fuels that are made from petroleum so that we could use them up to 100% in our tanks.
Okay, so I've got you here. I want to talk a little bit more about ethanol because I think it goes into the other products that you're trying to talk about. You always hear, like, it seems like every 5 years there's a new study. Okay, the carbon footprint of the production of ethanol fuel is, it's a net gain. You're actually putting carbon up into the atmosphere. Oh no, actually, it's a net benefit. So do you follow that? What's going? I mean, is ethanol really not a good way to go when it comes to biofuels?
With everything, it's all in how you make it. And one of the challenges in the past was with making ethanol is that it's made from corn. And corn is very water intensive and energy intensive to grow. And when we say energy intensive, it's energy in the form of petroleum fuels that are put into tractors and put into all of the machinery that goes into growing, planting, and harvesting corn. And that makes it very energy intensive, and therefore we're putting a lot of carbon in the atmosphere. So at best, it's probably break even in terms of carbon neutrality, but it's probably much worse in that we're adding more carbon to the atmosphere in making it. With the cellulosic biofuels that we are creating, they can be really net negative in terms of the amount of carbon put into the atmosphere. And part of that is in how you grow it. They don't require a lot of fertilizer. They don't require a lot of water. They don't require a lot of care of the plants. Rather than replanting every spring, as you would with corn, with something like switchgrass, you would cut it off and leave all the roots in the ground that then would regrow in the spring, so you wouldn't have to replant it. And the benefit of doing that is that there are microbes around the roots in the soil, and they store extra carbon in the soil. And so there have been several studies that have shown that if you produce biofuels from switchgrass or grasses like this, that you're in fact putting more carbon into the soil, pulling more carbon out of the atmosphere than what you are putting into the atmosphere in terms of making and burning the fuel. And so they can actually be net carbon negative.
So with the company that you're at, is the goal with the research and the technology is about making these various like potential fuels more efficient, or are you also looking at like how we can kind of scale it? What really is the proper crop to use in all this?
We're looking at all of those things. We're looking at what's the best crop to do it, how to tear that crop apart and extract the components of it so then we can transform those into fuels. And all along the way, we look at both the economics of doing it through what we call techno-economic models. These are computer programs, models that we put all of the inputs into it, and we try to predict what the price will be at the pump for the consumer. We also look at the sustainability, how much carbon we're actually pulling out of the atmosphere when we grow the crop, and how much is going back into the atmosphere when you burn the fuel in the car. And that includes all of the carbon for transporting the fuel from the production facility to the gas station, all of those aspects. And so we try to look at this and then build processes and do science that will minimize the price and minimize the carbon footprint and all other environmental footprints.
Well, okay, so you've mentioned like let's say a car, for example, but what are the fuel types that you're looking to produce biofuels for? I mean, just the car fleet. I mean, what else?
Right. So we're looking at gasoline replacements. We're looking at diesel replacements. I would say even more emphasis now is on jet fuel replacements, because if you think about it, eventually I think we'll have our automobile fleet converted to electricity. We're seeing that now. Very small percentage of our fleet is electric right now, but it's growing with time. And you see a lot of automobile companies switching over to electric cars, making electric cars. That's going to take decades to get all of the gasoline cars off the road. So it'd be great to have a biofuel for gasoline cars. Trucks will happen as well. And in fact, we see delivery trucks now coming that are electrified, and this will increase with time. What's going to be challenging, really challenging, is electrifying planes, because this is going to take an entire redesign of the plane. And you see some companies talking about having electric planes. At best, these will be very small planes. They will not be the planes that will cross the Atlantic or the Pacific, at least not probably in my lifetime and yours. So we really need fuels for jet engines, because that's one thing that's going to be the most difficult to electrify.
Okay, so explain that. What's the limiting factor when it comes to the airplane flight, when it comes to fuels and biofuels? It's something about the fuel needs to burn at a certain temperature, and you just can't do that very easily with biofuels. What's the issue there?
Well, so first of all, the reason it's difficult to electrify planes is because fuels are very energy dense, and batteries are not energy dense, and so you'd have to have massive batteries to get a plane off the ground, and they would take the full weight of the plane. With the biofuels, we have to have fuels that are directly mimic the fuels that we now use in jet engines, and that means that they have to have the same vapor pressures. They have to have they can't freeze at low temperatures, because when a plane is flying high in the atmosphere, it's minus 20, minus 30, minus 40 in the atmosphere. So the fuels can't gel up in the engines and in the lines that run to the engine. So we actually have to match all of the qualities of petroleum-based jet fuels when we're making biojet fuels.
Okay, and it gets following up on that. So you mentioned the battery density, and that's why it's hard to put those in planes. But with are we there? Are we close to providing biofuels as a fuel for planes? That's an area you're working on.
Yes, it is an area. So we can make the fuels that will match the jet fuel, the petroleum-based jet fuels. The challenge right now is economics, being able to provide these fuels, make these fuels in an economically viable way. Jet fuel, when United and American buy jet fuels, they usually have long-term contracts. They usually get pretty good pricing on that fuel, and it's really challenging to meet the prices of petroleum-based jet fuel, in part because we don't account for or don't charge for the carbon that's going into the atmosphere. That's starting to change. You see states using carbon credits, and even countries thinking about putting a price on carbon. And that will help get the biofuels to economic parity. But it also is going to require some more science.
Well, if you solve that riddle when it comes to plane flight, think of how many people, especially in the environmental community, worry about their carbon footprint when they travel by flight. And that's the one thing. Well, I can take different modes of transportation, but flight, it's hard to change. And so a lot of us are cheering you on to make it a more sustainable way to do air travel. Well, without revealing too many trade secrets, what's some of the most exciting research that you're working on right now?
Well, we've got research on engineering plants to be more efficient, to make more biomass, so that on a given acre of land, you could produce as much biomass as possible and use as little fertilizer and as little water as possible. And what that allows us to do then is to use land that wouldn't be used for producing food, maybe substandard land that wouldn't be used for producing food. We can use that now to grow these bioenergy crops. We're developing very efficient processes for pulling those plants apart and extracting all of the components of a plant. A plant's about 2/3 sugar, and we want to get the sugars out of that plant in a form that microbes will really like and will eat and transform into biofuels. And then we're working on engineering microbes to be as efficient as possible with those sugars that come from the plant, so that they convert as much of the carbon in the plant as possible into the resulting biofuel. And then finally, we're trying to make biofuels that directly mimic the petroleum-based fuels. And in some cases, we can even make energy dense molecules, more energy dense molecules than what you would get from petroleum. And so I think there's a lot of opportunities there. It's just a matter of time and research, as well as getting the price down.
Okay, I got a question here from the chat room, and Ken's asking, what about container ships? They suck up a lot of fuel as well. Does that come up for you, how you're going to transport a lot of ships
Yes.
out there?
Yep. And I didn't mention that, and I'm so glad we got that question, because that's another area that I think is going to be really important, and that we're doing a lot of thinking about. In many ways, container ships we're using the kind of the dirtiest kind of fuel, really kind of the bottoms that come out of everything else after you take the gasoline, diesel, and jet fuel off. You're kind of left with this sludgy stuff that's used in these container ships, and in many ways the dirtiest. And so that's also extremely important for us to replace.
Okay, a question, it's biofuels as part of the mix. In a previous life, I did a lot of kind of in Georgia, for example, like how they're using the biomass for those kind of things. But when you hear like the UN and you hear about solutions to climate change, and we're going to meet these renewable energy targets 50% by 2035, you hear mainly solar and wind. And, they talk maybe a little bit about it, but are you hearing much that biofuels, if the technology and the scaling gets there, is going to be a big part of the solution, or at least the transition?
It's been a challenge with biofuels, and again, we're trying to produce something that's competing with petroleum-based fuels, and there's not a price on those for burning them and putting carbon in the atmosphere. So that's been a challenge, and that's why I think fuels for planes and container ships are really important, because those are the kinds of fuels that will not be replaced through electrification. But you're right, there's a lot in the news about electrification and not so much about biofuels. I think we're going to get there, but and certainly the U.S. Department of Energy is putting a lot of emphasis on jet fuels and fuels for large ships.
What about the status of, like, you heard a lot, it seemed like there was a lot of stories about algae being a major source of potential fuels and stuff. Is that an area that's still getting a lot of research?
I would say it's certainly, there's less research than there used to be. And, one of the attractive features about algae is that if you just do a simple calculation about how much sunlight and carbon dioxide they're able to convert, say, per acre, it looks astronomical when you compare it to plants. But the challenge with algae is how to grow them, how to get the carbon dioxide into the water efficiently, and you need a concentrated source, which means that you're going to have to somehow concentrate it from the atmosphere. You need a concentrated source of sunlight, and when you grow these things in tubes, in glass tubes, exposed to the sunlight, they tend to get they stick to the outside of the glass tube or to the sides of the tube and shade the rest of the culture, because they want to get close to the sunlight. So it's been a real challenge to develop bioreactors at large scale. And then on top of that, once you grow them at large scale, you got to get the water out in order to get the oil out. And that's been a challenge as well. So, many of the companies that started with the promise of using algae to produce biofuels really haven't made it because of all the technical challenges around it.
So are you at the stage where you still need mass production of the biomass that you're going to use? Are you talking to countries yet, or do you think they'd be United States based where you get your biomass? Are you there yet, or is it still more of just on the research side?
So we've got a lot of research going on, but there's a lot of companies really interested and poised to do this. And we're working closely with several companies on this. We're working with plant crop companies on the development of energy crops. We're working with companies that would then process those crops and turn them into biofuels. We've even been working with oil companies over the years. But as I said, this has been economically very challenging, even for some of these very large companies. But I think we're going to start to see things change, because the boards of many of these large companies like Exxon are now demanding that they become carbon neutral, that they provide energy in a carbon neutral way. And so, if they want to be in the transportation energy business, certainly biofuels are going to be a really critical part of that.
Okay, I certainly don't want to miss out on the role of federal funding and the kind of work you're doing, especially with the institute that you're at. How important is this kind of funding for this kind of basic research?
It's really critical. The U.S. has had a long history of funding basic science, and this has resulted in the development of the transistor, development of all kinds of technologies that benefit us today. And similarly, the National Institutes of Health, which is federally funded, has developed a lot of therapies for human diseases. Just like that, the critical research that the U.S. Department of Energy is funding throughout the U.S. is really central to developing biofuels, as well as developing a number of other important sources of energy.
So is this similar work? You're a professor at Berkeley, but we haven't really dug into that at all. But is the work overlap completely, or are you doing kind of different things there?
No, it's all very similar. The research in my research group is focused on engineering microbes to transform things like sugar into useful products. And you mentioned artemisinin, the anti-malarial drug. We engineered yeast to produce this anti-malarial drug, and that's been commercialized. And we've done that with a number of other interesting products like flavors and fragrances, as well as some new classes of plastics now that will be highly recyclable, but yet produced from biomass. It really overlaps this whole area of taking biomass and transforming it into useful products like biofuels.
Okay, we got another question that just came in. What are the levels of public funding like in similar fields in like China recently? For China, for example, they
The US has always led the world in funding basic science, but we see a lot of funding now in China and other countries, and they're funding very similar research to what we're funding. And if you look at China right now, it's a direct scientific competitor with the US in many areas. There are a lot of people in China, and China is putting a lot of money into basic science. And so I think, we're going to see that the US has a lot more competition out there in the basic science arena and in technology development. But I look at that as long as it's all fair competition, I look at that as a really good thing, because that'll drive everybody to a higher level and get more science out. It just has to be at a fair level everywhere.
Okay, so as we wrap up this interview, just what's next for you? I guess we're all traveling a bit more, but like what's on your plate? Are you going to be able to get out, and is your work taking you to different places?
Yeah, so I used to travel a lot, and for the last 15 months, I've pretty much been in this office using whatever video conference system my colleagues want to use, and that's actually worked out quite well. I would imagine that I'll probably be doing some traveling in the future, and I would really love it if someday I'm flying on planes that have biofuels in them, and it would be even better if they were biofuels created by JBEI.
We're all looking forward to that day. I'm participating in this virtual conference for Managed Retreat and all the environmental types, and I'm sure they're looking for that sustainable way to travel by plane. So we're rooting for you. So hope to see that soon. Well, Jay, this has been a fantastic interview. I want to take you into just chatting, just a couple more questions, but we're going to wrap up the actual episode here. But thank you so much, and thanks for the work that you're doing.
Thank you.